Good afternoon, everyone. My name is Dr. Neil Patel. Welcome to this afternoon's Viva Learning session and presentation. I'm honored to speak in front of you. We have an extensive international group that is logging in as we speak, and I want to welcome everybody to the lecture. Today, I'm going to be discussing CAD/CAM workflow for implant-supported restorations using the CEREC system. Now, before I begin, I'd like to give full disclosure that I will be receiving an honorarium from IDS, who is one of our main sponsors for this learning session. I want to thank Viva Learning for hosting this presentation. Full disclosure, I also do receive honorariums for speaking for Dentsply Sirona, but certainly this afternoon, I'm just here to share my passion for what I feel is the future of dentistry. And the future of dentistry is certainly going digital with all of the technologies that we have available, spreading from laser dentistry, CAD/CAM dentistry, cone beam imaging for 3D diagnostic imaging for our patients, to using digital x-rays as well. So the technology these days is one thing that certainly allows us to elevate our clinical skill set, but perhaps one of the biggest discussion points in integrating digital technology is how to actually allow the technologies to work together for a more seamless and simplified workflow as it relates to restoring implants. So what I hope to do this afternoon is give you insight into what I've been doing in my practice in my private clinic in the United States. I'm located in a city called Columbus, Ohio, and I wanted to share with you something that we do routinely. Instead of talking about lofty concepts that often are difficult to integrate, I will share with you an easy workflow that allows clinicians to take implants from start to finish, not only in designing the implant position from a surgical standpoint, but also ensuring that the implant ends up surgically where it's been planned, and then restoring the implant with a simplified CAD/CAM approach that we use, again, on a daily basis. My hope and my dream is to leave a butterfly effect with everybody, and I hope that this butterfly effect is something that allows all the clinicians that are logging in to see how unique implant dentistry certainly can be. And so with that said, I'm going to give you some insight into some of the technology that I have integrated into my practice. Two of the main staples are CAD/CAM and cone beam. Now, I will be sharing a unique workflow that's exclusive to Dentsply Sirona and to Megagen, but certainly there are other cone beams and other CAD/CAM systems that also allow for integration, and certainly there are other methodologies in restoring implants from start to finish using chairside CAD/CAM. To simplify this process, let me first start by showing you a picture of two restorations that were designed and milled chairside. On the left, you see a hybrid abutment and on the right, you see a hybrid abutment crown. Now, the abutment that you see on the left is something that was designed and customized in the CEREC software, and the ability for the clinician to this and manufacture this chairside is here today. The ability for the clinician to decide how to restore that abutment is open within the CEREC software. And for those that have CEREC, you realize that there are so many materials that we have to pick, from which we can pick to restore an implant. On the right is a monolithic hybrid abutment crown. It is a screw retained crown that was also designed and milled with the CEREC system. But in order to do this hybrid abutment milled crown, there's only a few number of blocks that are available for the CEREC system that have a pre-machined hole. And I'll get into the details here in just a moment. Both of these materials that you see here for the abutment and for the crown are lithium disilicate, which is EMAX, available from Ivoclar. Integration is a concept where a clinician has the ability to scan a patient in 3D with cone beam and also scan a patient intraorally with CAD/CAM for the design of prosthetics. When we integrate these two technologies together, we are able to take data from the CAD/CAM machine and data from our cone beam X-ray and combine them together, we have a more seamless opportunity to treatment plan our implants and project our treatment guidelines for our patients. And today I'll share that concept with you. In order to integrate both of these technologies, certainly one must take a cone beam scan and a CAD/CAM impression. But to simplify the workflow, let me share with you a workflow that we've been using in our practice from day one. What you see here is a slide that tells you a linear workflow for a 3D digital implantology perspective. To begin, we normally take a cone beam followed by an optical impression. Once we have both of those scans at hand, we can combine them together so that not only can we see a virtual crown, but we have an opportunity to plan an implant within the three-dimensional anatomy provided by cone beam imaging. Once the implant has been designed, we have the ability to send the data back to our CAD/CAM machine, and there's an opportunity for us to also mill the surgical guide. The milled surgical guide is something that CEREC can do. It does require the 4.4 software, but with a milled surgical guide, we can actually perform guided osteotomies within one appointment. And once the osteotomies are provided, we can place our implant, and we can then utilize CAD/CAM technology to rescan the placement of our implant, design prosthetics, and mill our restorations. Now, I'm going to share with you a simplified workflow, but I need everybody to understand that the traditional methods of loading implants is still something that we honor. So although I'll be sharing a few cases with you where we can immediately load our implants, it is recommended that you wait the conventional 3 to 4 months for osseointegration to occur prior to engaging in restorative treatment. Let's talk about how this process works. For those of you who are not familiar with CEREC, I want you to understand that CEREC has an opportunity to do intraoral scanning as opposed to taking analog impressions. Within the intraoral scans, CEREC allows us to design veneers, crowns, inlays, onlays, abutments, and screw-retained implant restorations. In addition to that, we are needing to know some specific details on the parts and the pieces that are available to us in the market. In detail, I'll share with you this chart, primarily showing you the two systems that Megagen has to offer, both AnyRidge and AnyOne. Now, within this chart, you will see a list of implant diameters, scan posts, the CEREC software delineation, scan post codes, the Zergen type, the cuff height, and so on and so forth. My objective is not for everybody to read this chart and understand it, but to realize that there's several components that need to be understood prior to engaging in implant therapy using both cone beam and the CEREC system. So let's take it up to the next level. What you see here is a picture of a tie base. This tie base is manufactured either by Sirona or by the implant company themselves. This tie base acts as an interface between the material that is milled by the CEREC system and has specific connections that allow us to restore most of the major implant systems that are available on the market. So the connection that you see here is meant for the Megagen AnyRidge system. This tie base is manufactured by Megagen, and it's designed to act as an interface between the CEREC milled restoration and the AnyRidge implant system. Now, amongst the different implant systems that are available on the market, there are different sizes of tie bases that are available. Not all tie bases are the same. The CEREC tie bases in particular come in two sizes, small and large. Now, the small and large tie bases are designed to be integrated with the CEREC software, and specifically, they have a notch, which I will draw so that you can see where this notch is. This notch right here is designed on the abutment, but the materials at CEREC also has the ability to mill, including enamic and the Emax abutment block, have a notch already milled into the hole inside the block. I'll share a picture with you in just a moment, but that notch is very specific to the CEREC tie base. Now the connection itself, as you see here, is specific to the implant that you are restoring. The top part, which is the flute, right here, is the part that receives the component that is milled by CEREC. It can be an abutment or it could be a screw-retained crown. But when you combine those two elements together, the tie base and the crown, or the abutment, we combine them outside of the mouth and we deliver them as one piece, which is why they are called a hybrid abutment or hybrid abutment crown. As it relates to the CEREC system, and for most implant systems, we have the ability to delineate each of the tie bases as either being a small tie base, as you see here, or a large tie base. The small tie bases require that you mill a small block. The large tie bases require that you mill a large block. Now, some systems do not have a lot of flexibility, where one tie base may be appropriate for a certain dimension implant. The same tie base is available for the larger diameter implants. With MegaGen, they've developed 3 tie bases for the AnyReg system: the 3.9 tie base, the 4.3 tie base, and the 5.5 tie base. If we go back to the previous slide, you'll see that the 3.9 tie base is best suited for the 3.5 and 4.0 diameter implants. The 4.3 tie base is best suited for the 4.5 and 5.0 implants. And the large tie bases are best for the wide diameter implants for AnyReg. Now ultimately the clinician can use any tie base for any implant, since the AnyReg system has one prosthetic connection across the 3.5 all the way up to the 8.0 implant. So these are the 3 CEREC abutments that are available for the AnyReg system. The first one on the left is a small tie base, and it's a 3.9 tie base. The middle picture represents the 4.3 tie base. The difference between these two is the actual lip that you see here. So the 3.9 tie base is right here with a smaller lip. The 4.3 tie base has a 4.3 diameter, as you see here, lip. And the 5.5 has a larger platform onto which the milled component can seat. Now the two on the left, both the 3.9 and the 4.3, have a small tie base interface, which is a 3 millimeter diameter dimension. The large tie base, which is the 5.5 tie base, is a large tie base, and its chimney is 3.4 millimeters in dimension. So for the large tie base, you have to make sure you use the large block. For the 2 small tie bases, you have to make sure that you use a small block. So here's a summary. The top row are the tie bases available for the AnyReg system: small, medium, and large. The small one is 3.9 millimeters in diameter for the lip. The medium one is 4.3 diameter for the lip. And the large one has a 5.5 diameter for the lip. The tie bases are actually what get glued inside of the milled restoration, whether it's an abutment or a crown. Now the tie bases can also be used to scan. The problem with the tie bases is that sometimes when they are seated intraorally, this component fits below the gum line. So for those implants that are placed deep, this tie base often can get lost underneath the gum line and can be difficult to retrieve, but more importantly, can be difficult to line up the notch with the scan body. So what most companies have developed is a scan post. Now both the tie bases and the scan posts are unique to CEREC when it comes to the CEREC workflow. Other manufacturers also call these scan posts scanning flags. They are available for other softwares as well, including 3Shape, including ExoCAD, and some other third-party CAD/CAM programs. The scan post is specific to the CEREC workflow. Now, the benefit of the scan post is that it allows a clinician to scan intraorally without the risk of losing the tie base subgingivally, and additionally, it allows the clinician to identify the notch that is visible in the tie base. It elevates the platform so that this notch is visible above the gum line so that the clinician can line up the scan body. I'll explain in just a moment. So on the top we have tie bases, and on the bottom we have scan posts. Both the tie bases and the scan posts can be scanned intraorally, but the scan post is specifically designed for intraoral scanning. The tie base is specifically designed for model-based scanning, since the clinician can retrieve the tie base much more readily on a model versus intraorally. Ultimately, once you've scanned either the tie base or the scan post, the tie base itself is glued to the CAD/CAM restoration, allowing us to deliver that restoration to the implant. Now, these are the model numbers for each of these specific components. I'm certain that we'll be able to share this presentation after it's been provided through Viva Learning, so that for those that are interested in ordering these parts and pieces directly from MegaGen, you'll have the appropriate numbers. The scan body is the last component that needs to be understood. Once the tie base or the scan post is seated in the patient's mouth, the clinician has to attach a scan body to the tie base or the scan post. This scan body is detected by the optical scanner of the CEREC system. It comes in both white and gray. The white scan body is intended for the blue camera. The gray scan body is intended for the new OmniCam from CEREC. Both can be used depending on the scanner that you have. They come in both large and in small. Depending on what country you live in, they are distributed by most dental manufacturers, or distributors rather, but certainly can be bought directly through Sirona in certain countries. In the United States, these scan bodies are sold through Patterson Dental. And you see that they come in packages of 36. So you have to pay attention when ordering to make sure that you're picking the right color depending on the scanner that you have. Again, the gray one is intended for the OmniCam. The white one is intended for the blue cam. Now the gray one comes in both large and small, as you see here. OmniCam large, OmniCam small. The small one that you see here will fit a small tie base. The large one will fit a large tie base. Similarly, the white large one will fit a white large tie base, and the small scan body will fit a small tie base. So those scan posts and tie bases for any ridge are divided, as you see here, by this blue line. The two that you see on the left are meant for the 3.9 and the 4.3 tie bases. They do require a small scan body. And the large tie base that you see here on the right requires a large scan body, because the chimney on the large tie base is designed for the large scan body. In addition to this, you'll see that when you're selecting the software, you have to make sure that you select the right interface in the CEREC software for 4.4 software. The 3.9 tie base for the AnyRedge system requires that you select FX 3.4 in the CEREC software. The 4.3 tie base requires that you select FX 3.8. The 5.5 tie base requires you select FX 4.3. When you select 3.4, 3.8, or 4.3, it automatically tells the software the exact location of the implant and its rotation so that the prosthetic connection lines up correctly. So let's take a look at our first patient case. This is my brother-in-law. He is the first patient to have received a scan post from Megagen, designed chairside with CEREC, and seated chairside with the CEREC workflow. What you see here is a large diameter implant placed at site number 46. In the US, it's tooth number 31. On the left, you see a transgingival healing abutment, and on the right is the removal of the healing abutment, and you're looking at the fixture level of the implant itself. Now, because we're using a molar-sized restoration to restore this patient, we're going to be selecting a larger tie base. And as you recall, there were 3 options for the AnyRidge system. We have the small, the medium, and the large. In this instance, I was able to use a large tie base. So the first thing that I do is once the healing abutment is removed, I will then seat a scan post. Now before I do so, let me share with you the preoperative image. This is tooth number 46 rather. You can see that it had a failing endodontically treated tooth with a root fracture at the furcation. This is a CT slice image of tooth number 46 or tooth number 30. The tooth was planned for replacement with an endosseous AnyRidge implant. This is a 5.5 by 11 millimeter implant. And you can see that this was planned in cone beam in 3 dimensions. Here is our immediate placement images. Implant was placed in the furcation bone. It was grafted, and upon healing, we seated this. This is the scan post for the CEREC AnyRidge system. This scan post allows us to scan intraorally. Now, I could have also seated the tie base directly in the patient's mouth, but the tie base would have ended up subgingivally, making it very difficult to line up this scan body with this notch. Visible detection is required so that the clinician can properly align this notch of the scan body with the notch of either the tie base or the scan post. Here's what the scan post looks like when it's seated intraorally. Now, if you pay attention, you will see that the notch is facing the proximal surface. It's important to face this notch on a proximal surface because during the design of this CAD/CAM restoration, the sprue will be 90 degrees from this notch. Hence, the sprue will either be towards the lingual or the facial. If we place this notch on the facial, then we run the risk of having our sprue on a contact point, which makes for more complex adjustments during the seating of the restoration. Once we've seated this scan post, it's appropriate to take an intraoral X-ray to confirm that the scan post is seated properly. Once it's confirmed, we can then visibly identify this notch and seat the scan body, lining the scan body notch exactly with the notch that's on the scan post. With this component completely aligned, we are now ready to take an optical impression. Now with the CEREC system, before we take the optical impression, it's important to understand how to actually list the information within the administrative screen. This is a screenshot of the administrative screen for my brother-in-law. You'll see that on the left, we have to select an implant restoration. Then we have the ability to either design a screw-retained crown or a multi-layer abutment and a crown. If we knew that the screw hole was going to be in an aesthetic zone, For example, if we were working on an anterior tooth and we knew that the draw of the implant would force the screw hole to be on a facial surface or on a functional cusp of our premolar, for example, then it's in our best interest to split the file and use this multi-layer abutment. This allows us to actually generate a separate abutment and a separate cement retained crown. If we plan our implant properly, we have the ability to also fabricate a screw retained crown. This is a one-piece screw retained crown, and this avoids the risks of cement sepsis, for example. The benefit of a screw retained crown is that it only requires one block, and it truly has great accuracy in terms of restoring our implants due to the limitation of additional components. Now, in the design mode, we've selected biogeneric individual. The material of choice in my clinic has been IPS Emax lithium disilicate. I will be selecting scan post as the scan body type. If we seated a scan tie base inside the patient's mouth, we would actually select tie base in this segment here. The manufacturer of the tie base is Megagen, but because Megagen is not currently in the CEREC 4.4 library, we have to select Sirona as the manufacturer and demarcate the tie base similar to a Xive implant. So the tie base that we will be selecting is the FX 4.5 for the large scan post and the large tie base. So I've selected FX 4.5 right here. Let me go back to the previous image so you can see where that number came from. If you recall, we decided to seat the patient with this large scan post for a molar restoration. It has a larger lip, as you see here in the tie base. We seated a gray scan body, and in the software we had to select FX 4.3. The other two tie bases and scan posts require a different selection of the software, so that if we seated a small tie base or a small scan post, we would have to select FX 3.4. If we selected the medium tie base or the medium-sized scan post, we would select FX 3.8. Back to our presentation. So now you see where we selected FX 4.5. Let me zoom in so you can actually see closely exactly what we've filled out for our administrative screen. Again, we've selected an implant restoration, screw retained crown. The design mode is biogeneric individual. The material we've selected is IPS Emax. The scan body type is a scan post. The tie base manufacturer, we select Sirona. And again, because it's the large scan post that we're scanning, we've selected FX 4.5. Once this has been selected, we can click Next. At this stage, we acquire our images. We can acquire an optical impression of the lower arch, as you see here, for tooth number 4-6 or tooth number 30 here in the United States. You can see the gray scan body. You can see a hint of the notch that's on the scan body lined up with the scan post. You can see the anatomy of the gingiva and the gingival cuff heights. You can see the proximal contacts and the surfaces of the adjacent dentition. Okay. Once the image has been acquired, we can actually select Next. I'll take you through some images, some snapshots of our optical impression, so you can see how the software understands that we're actually scanning a scan post as opposed to a tie base. If we put a tie base in this patient's mouth, the tie base would be located very subgingivally, making it difficult to seat this scan body correctly. Since we were able to use a scan post, you can see that this notch is clearly visible, and this helps the clinician to seat the components more accurately. Now what we can do is we can also make the optical impression transparent, so you can see that the software understands the location of the implant based on the actual scanning of the scan post. Here is an image that shows the actual tie base that's virtually seated on the implant. Now this is the tie base that would actually get glued or cemented to our CEREC restoration. Again, this tie base could also have been used intraorally, but you can see that this tie base seats very subgingival, making it difficult to detect the notches and lining up the prosthetic components. Here is our design for site number 46 or tooth number 30. And you can see that the sprue is 90 degrees from where the notch was located. This allows for more accurate proximal contacts and helps the clinician in manufacturing this restoration. Here's what the tie base looks like, along with the location of the implant. Here's the tie base by itself. And here's how the restoration would fit the tie base. Once this crown is manufactured, it has to be fired, and I'll share with you how we can actually attach this crown to our tie base. Once these two components are glued together outside of the mouth, it can be delivered as a single prosthesis as a screw-retained hybrid abutment crown. Here's what the crown looks like inside of the Emax block. Now the Emax block itself already has a hole milled inside of it. This Emax block is very specific to the CEREC abutment workflow. This Emax block is completely different than your traditional Emax block for CEREC, in that it is specifically designed for the implant restoration. So what you see here now is basically the restoration design inside of the block, and I'll scroll forward through this presentation so you can see how these components actually fit together. Now, it takes about 15 minutes to mill this restoration once it's been designed. And here's how all the components fit together again within the CEREC software. Here's a view of some of the blocks that are available. You see Emax, TeleoCAD from Ivoclar as a temporary material for those that want to provisionalize. We also see Enamic from Vita. We also see CAD Temp from Vita as well. Additional materials will come out in the future, but you'll see most of us using Emax, as it's been around for quite some time on the market. The blocks have to be ordered specifically both in the dimension that's required as well as the hole size, which again is delineated by the size of the tie base. This L can only be used for the large tie bases, as this hole is a large hole meant to fit the large tie bases. The 2 out of the 3 tie bases for the AnyRidge system require the small block. The large diameter tie base requires the large block. They come in both A14 as well as 16 sizes. Here's a representation of an abutment as well as a hybrid abutment crown. What you see on the left is a split file. We have the ability to split the file so that we can make a separate abutment and a separate crown. Or, what seems to be most popular today, is a crown that is glued to the tie base for a screw-retained crown, eliminating the need for an abutment altogether. To combine the components together, what you have to do is block out the base of the tie base attached to a lab analog, as well as fill the screw channel hole and sandblast with aluminum oxide. This prepares the surface for bonding. Once the surface has been blasted with 29 micron aluminum oxide or 27 micron aluminum oxide, the clinician or the technician can then steam clean the abutment, use a metal primer such as Monobond Plus from Ivoclar, block out the screw hole with a sponge or a cotton pellet, hydrofluoric acid etch either the abutment or the crown for 20 seconds if it's made out of lithium disilicate, apply Monobond Plus to the crown, and use multi-link hybrid abutment cement to lute the components together. I like this cement because it actually blocks out and masks out the actual tie base. What you see here is the amount of cement that's needed. but it's heavily coating the tie base itself. And once it's been coated, the clinician can actually coat the inside of the abutment or the crown and line the components up correctly as you see here. Once the components are lined up, this material takes 7 minutes to fully cure and set. Once it's set, we can take a rubber wheel and polish off any excess cement, essentially creating either a separate abutment or a screw-retained crown, ready to be seated. And here's the restoration for implant number 46, the same day as its seat. Here's the occlusal view, and more importantly, here's the x-rays to show you the proof in concept. So here's the implant the day of extraction, and here's the implant once everything has healed 3 months after extraction. You can see that the bone has filled in quite nicely. Now in this image, you can see that the tie base is not fully seated in the implant. So this is not seated correctly versus this one, where you see that the tie base is fully engaged inside of the implant with all the components seated correctly. Now, the digital workflow starts with the end in mind. CEREC integration is not just about the restoration, but with the appropriate CAD CAM and cone beam, the clinician has the ability to actually plan everything ahead of time, including the actual placement of the implant. Here's patient number 2. This patient was referred to my practice due to a need for the removal of tooth number 11 or tooth number 8. Here's the x-ray showing the actual implant placement, the tie base, and these x-rays show the need for the removal of tooth number 8. Now with CEREC and cone beam, what we have an opportunity to do is merge the data sets together. So here's an optical impression where we can actually design a virtual tooth that's missing. Here's tooth number 11, which is a virtual wax up for the missing tooth. With this virtual wax up, we can combine this data with our cone beam. The cone beam that would be required for CEREC data would be either the XG3D, the Orthophos SL, or the Galileos from Sirona. Combining these together allows the clinician to actually see an optical impression of the soft tissue, the virtual tooth that we're replacing, and plan for an appropriate implant. As you see here, we've planned for an AnyRidge implant for immediate placement. The concept was designed so that we can deliver a screw-retained restoration as well. Once this data set has been combined, we can actually send this data using the export button from our cone beam machine back to our CAD CAM design software. When we open that file back inside of the CEREC software, we have the ability to actually design a surgical guide specifically for the implant that we just planned. Here, we actually modify the optical impression and the seating surface for the surgical guide. We select the drill key support, and we have an opportunity for the software to automatically design a surgical guide for us. We can customize it by putting in seating windows, as you see here, and we can actually mill this surgical guide out of a block. Now it is required that you have the carbide drills, both the RZ25 drill and the Shaper 10 or Finisher 10 burr on the right side. The 2 blocks that are available to mill surgical guides chairside include a large block, which is the maxi block, and a medium block. Once a block is inserted, it does take 45 minutes to manufacture or to mill. Once it's milled, we now have a surgical guide designed chairside for immediate implant placement. A key is used to control the osteotomy, and essentially, once the osteotomy is provided, we can place our implant exactly where we planned it. And at this stage, we can actually use our scan post, as you see here, seated intraorally the day of surgery, scan back into our CAD CAM CEREC design software so that we can actually design a restoration and actually seat it the day of impressioning. Now, a few things that we've designed into this restoration, as you see here, is that natural sigmoid shape that Dr. Park discusses, the owner of IDS Megagen. You can see here, this is the point of biologic width. This is the point of aesthetic emergence, and we can combine those two together through a sigmoid-shaped S-line. This allows for really nice aesthetics and a proper emergence profile. Additionally, we can use ISQ to understand our loading stages, and we can control the outcome using a complete digital workflow. Here you see a CEREC Emax abutment restoration, finished, and this is the final outcome, chairside, all using CEREC. Now for more complex situations, as you see here, this is the patient who is missing both tooth 1-1 and 2-1, number 8 and number 9, and she needed to have implants to restore 2 teeth that were failing. You can see both implants were placed and provisionalized. And at this stage, we use the same concept using CEREC to scan intraorally as opposed to taking analog impressions. Now in the next image, you'll see that we can remove our 2 provisionals, screw retained provisionals, and see the quality of the tissue that we've created through our prosthetic provisionals. Instead of using the scan posts, we seated the tie bases because we had clear access to understand where this notch was located. So you can see that the tie base is used in this case as opposed to the scan post. So the tie base is seated directly to the implant, as you see here. Here is where you can see the notch on the tie base on both of these tie bases. And at this stage, since we used 2 of the smaller tie bases, we would use 2 of the small scan bodies and align the notches of the scan bodies with the scan posts. Here is an occlusal view of the 2 tie bases and the 2 scan bodies attached to our 2 implants. At this stage, we can take an optical impression and design our restorations. Furthermore, today we have the ability to actually print our models. So instead of just virtually designing our teeth, we can actually also print our models to verify the seat, to verify contours, and also to have an analog model on which we can try our restorations, as you see here. What you see here is a full CAD/CAM reconstruction of the maxilla, and this is the seated restorations the same day as our seat for the 2 implants and the additional teeth that the patient was interested in restoring. Here's our patient after, and hopefully that gives everybody an insight into the workflow for our 2 restorations. With that said, I'd like to play a little brief video, hopefully inspire everybody to start thinking about the digital workflow as it could be implemented in their practices. It all starts with having confidence in the implant system and the technologies that we have access to today.
Confidence. Confidence is what guides you throughout your life. It brings you toward your future, to where you're going. It's about not being afraid. It's about being who you are. Discovering who you are. With it, you'll never be lost. You'll be forging your own future. You want to know the secret? Confidence walks together with success. It's about working hard and never knowing a challenge you can't overcome. Never accepting that you can't do something you love. It's about using knowledge and technology to discover your dreams. To find your true self. You plan for it and expect the best results. You can see the outcome before it even happens. Your state of mind will help others discover their passion, courage, and love. Confidence is more than a word. It's a choice. It's a way of life. It's about putting your dreams, hopes, and ambitions into action. You become a leader, and the results will speak for themselves. You take aim and accomplish what you set out for. You find the inner strength to be more. There's no question that it suits you. Others will see the passion in your eyes. It will shine wherever you go.
Well, I hope everyone enjoyed the presentation. I apologize for the few technical difficulties we had on my end. I apologize for dropping the connection. But at this point, I would love to answer any questions that the audience may have. I realize that we have clinicians from all over the world, and certainly I'll do my best to answer any questions that are being posted as we speak here. So I'll wait for the questions to populate, and I'll be happy to answer them as they come in. We do have one question that's shown up just now. The question is what can I do if the implant system I use does not have a tie base in CEREC? Well, CEREC currently only has a very few limited number of tie bases. Most of the major manufacturers, including Astra, Xive, Zimmer, 3i, Nobel, are some of the ones that are offered within the CEREC software. If a clinician has an implant system that is not one of those major implant systems, we have to use one of those systems as an alternative choice when we're actually scanning and designing. Certainly some systems have a Zimmer compatible connection, so we would simply select Zimmer as the compatible restoration or implant delivery option. The next question I have is, how do you know when to use a tie base or a scan post? In which case do you use a tie base or a scan post? To answer this question, I will tell you that both the tie base and the scan post can be used when scanning with CEREC. How I use it in my practice is I evaluate how deep my implant is. If my implant is very deep, subgingivally, I try to avoid scanning a tie base intraorally, because often when I use a tie base subgingivally, it's very difficult to line up the scan body with the tie base. Remember that the scan body was the white cap or the gray cap. Furthermore, when the tie base is seated too far subgingivally, it becomes very difficult to retrieve or remove from the patient's mouth during the scanning process. The scan post was created specifically for intraoral scanning. So it's my opinion that anytime you want to scan intraorally, it's in your best advantage to take use of the scan post for intraoral scanning. We do have another question here. Could you please explain more about the selection of the tie base size in relationship to the implant brand and size? Show the table one more time. I'd be happy to show that table. Let me go back to the original table. So this would be unique to every implant system. But for the AnyRidge system, for example, from MegaGen, you can see that if you have an implant diameter of 3.5 or 4.0, it's in your best interest to use a smaller scan post or a smaller tie base. For a medium-sized implant, such as the 4.5 or the 5.0 diameter any ridge. It's in your best interest to use the medium scan post or the medium tie base. And for large diameter implants, such as the 5.5 diameter implant or larger, it's in your best interest to use the large scan post or the large tie base. Hopefully that answers how we actually get to use the different size tie bases based on the diameter of the implant that you're planning on restoring. The next question is about the zirconia abutment. The question is it the same procedure as the tie base and the scan post? The zirconia abutment is actually different with CEREC. When you want to make a zirconium substructure, whether it's the actual abutment or the actual screw-retained crown, it certainly does have the ability to design and mill zirconia. More importantly, you would have to also have a zirconium firing oven to ensure that you can properly sinter the zirconium material. Now, CEREC does not have the ability to make an actual zirconium connection. The tie base is the actual interface that combines the zirconium with the tie base into the restoration. So CEREC does not have the ability to actually mill the interface. The interface is always the tie base. The next question, is there any way to use a scan body with the stock abutments for cases where the abutment is subgingival and difficult to image perfectly? There is not a way, unfortunately, to image a scan body with stock abutments. The clinician certainly has the ability to retract soft tissues and use a stock abutment as the actual scanning abutment or prep, if you will. But in order to actually use a scan body, you have to have direct access to the implant. So unfortunately, there's no way to actually use a scan body with a stock abutment. So it looks like our questions have come to an end. I appreciate everyone's attention. I want to thank IDS Megagen for sponsoring this Viva Learning session. I also want to thank Viva Learning for hosting this presentation. And I look forward to helping everybody on their journey in terms of digital dentistry and CAD/CAM integration. Have a great afternoon and a great day, and cheers.